Okay, welcome back. So we were trying to see how we can solve this system which we had introduced earlier. Uh, Maybe I can take that and place the whole system here. Then that way it will might be easier for us. Just give me a second. Let me copy that here. Okay, so let us now try to solve this example here. Fine. So we calculated the entropy of the system S by using the formula which we have earlier done. So let me write that formula as well. So H of S is equal to minus times summation Pi log of Pi. Fine. And in our case, the probability of yes was 9 by 14, probability of no was 5 by 14, and in that case we came up with the entropy of the system equal to 0.940. Fine. So now the question is which attribute do we have to select? Fine. So for that purpose we have to calculate the gain of each of those attributes. Fine. And to calculate the gain of each of those attributes, we first have to calculate the entropy of each of those attributes. Fine. So let us take the example of wind. Okay, let's take the example of wind. Now to calculate the gain of wind, so let me write that out here. So gain of wind here is equal to the entropy of the whole system S minus times summation I running from 0 to n, probability of x times the entropy of x. I will explain what that basically is. So what we basically have to do, because wind can either be here, if you see in this case here, it could either be weak or it could either be strong. Fine. So these are the only two possibilities which we have. So we have to find out what is the what happened here. Just give me a second. Okay, we have to find out what is the entropy of wind equal to weak. Okay, wind equal to weak. Let me see. What is the entropy of wind, weak wind, and what is the entropy of wind when it is strong? Fine, these are the two possibilities which we have to see, and to calculate that we also have to find out what is the, I'm sorry, it's getting going to the next one. We also have to find out the probability of this S when the wind is strong, and probability of S when the wind is equal to weak. These are the things which we have to calculate. Now let us assume, so let me take this away from here. So now let us take the case when the wind is weak when the wind is equal to strong, and then the total. So we have total number of 14 examples in total. In how many number of examples is wind equal to weak? So we just simply count it. 1, 2, 3, 4, 5, 6, 7, and 8. So in 8 number of cases, the wind is weak, and consequently in 6 number of cases, the wind will be strong. Therefore, the probability that S of weak. Now, what we have to do there is, what is the number of weak divided by the total number? Fine. So that becomes equal to 8 by 14. Similarly, probability of S strong will be equal to 6 by 14. Fine. So that gives us it. And then finally, the entropy of S strong. Entropy of S strong is basically, then we have to calculate out of the 6 examples, in which wind is strong, how many are yes and how many are no. Please understand it. So in both the cases, so whether we select wind weak, wind strong, in case it is weak, how many are then positive and how many are negative? Yes and no. In case wind is strong, how many are yes, how many are no? So that we have to calculate. Fine. So in case it is strong, we have 6 total. Among those 6 total, how many are yes? That is basically 3 examples are yes, in which the outcome is yes, and in 3 examples the outcome is no. Fine. So then H of S strong is basically then minus times 3 over 6, okay, log to the base 2 of 3 over 6, okay, and minus times again 3 over 6, because the other possibility is also the same, log to the base 2 of 3 over 6. And if you find that entropy is equal to 1. Why is that 1? Intuitively you can see it, because there is complete uncertainty in case of wind is strong, because 50% of the cases it is yes, 50% of the cases it is no. However, in case of weak wind, the entropy is slightly different. There is some order there. So if you see out of the 8 cases in which the wind is weak, 6 out of those 8 are belonging to the yes class and 2 are belonging to the no class. Therefore, the entropy is basically minus times 6 over 8 log to the base 2 of 6 over 8 minus times 2 over 8 log to the base 2 of 2 over 8. And if you calculate it, this will come out to be equal to 0.811. Fine. So we found out this part here and this part as well. Fine. The probability of wind equal to weak, wind equal to strong, and the corresponding entropies as well. And then finally we can now find out the information gain. Okay, so let me try to carry this somehow up or down. So this, fine. Okay. Okay, so let me hide these two, okay, because there is less amount of space available now. So we got the probability, and we also got the H of S weak and H of S strong. This is equal to 0.811 and this is equal to 1.000. Okay, this is equal. Now information gain then is H, information gain pertaining to the system S upon selecting the wind attribute. Fine. Or in other words, what is the information gain? When we select the wind attribute is equal to the total entropy of the system, that was 0.940 minus times sum of these things. So minus times summation of P of P of S week times H of S week plus, okay, plus P of S strong times H of S strong. Okay, this is the entropy. Sorry, this is the information gain. That is equal to 0.940 minus, we have these values. This is 8 by 14 times 0.811 plus, okay, plus this is this another one is 6 by 14 multiplied by 1, and that finally comes out to be equal to 0.048. This is the information gain which we have when we select the wind attribute. Fine. Similarly, you might calculate in case of what is the information gain when we select, okay, so gain, the other one is outlook, and then we have temperature, and then we have humidity as well. Fine. So wind we did. In case of outlook, it is 0.246. In case of temperature, it is 0.029, and in case of humidity, it is 0.151. Now you can see here, outlook has the most information gain. Therefore, we will select the first attribute of the tree as outlook. Fine. So the first attribute to be selected will be outlook. So we will place the root node as outlook. So outlook, and then we might have different cases here. The first one is sunny. Okay, it is sunny. Then we have overcast, and then finally here we have rain. Now in each of these cases, then we have to proceed. Fine. So outlook, and then from outlook, now we have to add this level number 1. Now we have to select the next node. In case it is sunny, again we will calculate what is the now the entropy here at this point of time. We will calculate the entropy here, we will calculate the entropy here, and we will calculate the entropy here. These will become the HS now. Fine. We don't have to now take this entropy. We'll have to now take the next entropy, H of sunny, H of overcast, H of rain, because here there will be some number of yes and some number of no. Again, here will be some number of yes, some number of no. Here will be some number of yes, some number of no. Maybe I might show you that one. So let us say H of sunny. H of sunny will be equal to, okay, what is the number of in case of sunny, what is the number of yes? So sunny, sunny, no, no. Again there is sunny, it's no. Again there is sunny 1, sunny 2. So there are 2 cases in which it is yes. So 2 out of, what is the total number of sunny? 1, 2, 3, 4, 5. 2 over 5. Fine. That is the probability multiplied by, so the minus time is multiplied by log to the base 2 of 2 over 5, and then minus time is 3 over 5 log to the base 2 of 3 over 5. This will be the entropy of our sunny. Fine. So we'll place that entropy here. Similarly, we will find entropy here, and we will find the entropy here. Then at this node, we will then have to find out which of the attributes do we have to split upon. So now we have only 3 attributes: temperature, humidity, and wind. Okay, temperature, humidity, and wind. So again, we will find the gain of temperature, gain of humidity, gain of wind, whichever that becomes. So we will select that attribute here. Fine. So once we reach a state where one side has all the yes attributes, the other side has basically if a leaf node is pure. Fine. So let us say we reach it here, and there were 5 cases in which it was sunny, and no case in which it was so 5 yes and no, 0 no's. Then we say in that case it's a pure node. Fine. It's a pure node, and we can directly say, okay, we have reached the decision. Fine. And at that point we will stop at this case. Fine. And we will then similarly do the other things. And finally, if you proceed in this way, we will have our final decision tree, as I had shown you in the first case. And that is basically, we will have the outlook first, then we will have three cases here. Here it will be yes, and then we will then again decide upon humidity, and here we will decide upon wind. Okay, and then here it will be yes, sorry, it will be no in case of high, and in case of normal it will be yes. Here in case of strong it will be no, in case of weak it will be yes. So that will be, in that case, if you proceed, you will ultimately get the decision tree. Fine. By the way, this way of generating the decision tree is using an algorithm called as ID3. Okay, using an algorithm called as ID3. There are other algorithms available as well, but ID3 is one of the algorithm. Its full form is information dichotomizer. I think that is the full form, but you can look it out for you on your own. Fine. So that was the brief introduction about the decision trees. Information gain and entropy is one way of doing one way of generating the decision tree. The other way, rather than using the information gain, we have to choose attributes such that entropy is decreased. And then shouldn't we choose that attribute which gives the, no, we will, no, how can we select that attribute which gives us the minimum gain, since we have to decrease? So this 0.246 is the amount by which the total entropy was decreased. Fine. So this factor should be as high as possible. How, I think you got a bit confused there. So this factor is, this number is the factor by which the total entropy of the system got decreased. Okay, total entropy of the system got decreased. So the higher this factor is, the better that that attribute is. Okay, I think that is very clear. Yeah, fine. And I showed you only this way of doing this, generating the decision tree. There are other ways. And other algorithms. There is C4 algorithm. There is a CART algorithm, and similarly for measuring the impurity of a particular node. In addition to using the entropy, there is another measure called as the Gini as well, which can also be used to measure the impurity at a particular node, or the purity of a particular node. But the main concept remains the same. Fine. So with those words, I would like to conclude this lecture, and in the next lecture I might show you an example again by coding it, and then we might move on to the next topic as well. So before I wind up, if anybody has any question, please ask. Okay. Yeah, I forgot to share the SVM material. I will share it. Fine, I would share it. Fine. So with that, let's conclude this today's session, and I hope this proved beneficial to you. By the way, I have used quite a number of videos and other material for delivering this lecture. A link of all of those I will post in the Google Classroom. Fine. So please go through all of them. Those are very beneficial videos. In particular, I would like to recommend the videos of machine learning videos of Sebastian Reshka. I don't know the full, whether I am pronouncing the name correctly or not, but he is a very good good teacher. I think he teaches in MIT or somewhere. Please go through his videos as well. I will post the link to all of them as well. Fine. So with those words, let me conclude today's session, and have a good day.